Hello, everybody. Today's lesson is on 8.4, trigonometry applications. We're going to begin this lesson with just a review of the things we learned the last couple of lessons. We have learned how to use trigonometry to find different variables like x. So for this one here, if x is an angle, we need to use our trig values. Again, it might be helpful to remember that sine is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent side over the hypotenuse. And tangent is equal to the opposite side over the adjacent side. So if you wanted to find x, you just need to identify your sides. 5 is next to x, so that's your adjacent side. 30 is the hypotenuse, because that's the side across from the 90, the longest side. That's always your hypotenuse. So if I've got the adjacent side and the hypotenuse, well, adjacent and hypotenuse, that would require a cosine. So to solve this, I would use a cosine. The cosine of my angle, x, would be the adjacent side, 5, over the hypotenuse, which is 30. To get x by itself, we just need to get rid of the cosine. The opposite of taking the cosine of something is taking the cosine inverse. So if I take the cosine inverse of both sides, the cosine inverse of the cosine of x, that would be the same thing as the cosine inverse of 5 over 30. Cosine inverse and cosine are opposite functions, so they undo each other. I get x by itself. And then I can just do cosine inverse of 5 over 30 in my calculator and get my answer. Cosine inverse of 5 over 30. Cosine inverse of 5 over 30 is 80.4 degrees. All right. We can do the same type of thing to find this x over here. Just identify your sides. In this case, there's my angle. So x is across from that angle. It's opposite it. So that's my opposite side. This 13, that's right next to the angle. Next to means adjacent. So that's my adjacent side. And opposite and adjacent, that requires tangent. So to solve this one, I would write the tangent of my angle, the tangent of 35 degrees. That'll equal the opposite side, which is x, over the adjacent side, which is 13. And then you just solve that. Tangent of 35 is just a number. Plug it into your calculator to see what it is. Tangent of 35 degrees is 0.7002. 0.7002 equals x over 13. So to get that x by itself, we got to multiply both sides by 13. Those x's cancel out, and I get x by itself. And 13 times 0.7002 is about 9.1. Oh, and that was measured in feet because it's a distance. The other x was measured in degrees because it was an angle. There it is. All right, so that's stuff we have been doing. Today, we're just going to keep doing that, but we're going to do applications. We're going to apply trigonometry in real world situations. So we're going to just be using trig to solve real world problems. There's a couple of vocab notes you might want to make note of. First being angle of elevation. Angle of elevation is just the angle above horizontal that an observer must look to see something above them. So if you've got a person right here and they're looking up to see something, there's my horizontal. This angle is the angle of elevation. Angle of depression is just the angle below the horizon an observer must see when looking at something below them. So if I've got some person standing on a cliff or something, and they're looking down to see something, Oh, I see something right here. Maybe, I don't know, a weird animal. It's a very weird animal. The angle of depression would be the angle that they're looking down from horizontal. All right, so I've got a picture here. A woman in a lighthouse is looking down on the incoming ship. Which of these angles is the angle of depression? Answer? It's X. She's looking down on the ship from horizontal looking down. It'd be that angle right there. Same picture, but this time we got a man and the ship is looking up to the lighthouse. Which angle is the angle of inclination? The angle of looking upwards. Well, the angle of inclination would be the one going up from horizontal. Here's horizontal, that's going upward. That's the angle of inclination. It's a weird picture. I know it's not perfect. Apparently this man is like standing right here. That's where his eyeballs are. He's like riding the bottom of the ship. That's kind of crazy, but I hope we get the idea. All right, I'm just going to do a couple examples. This one says a forest ranger spots a fire from his 300-foot watchtower at an 11-degree angle of depression. How far away from the fire is the base of the watchtower? All right. This says I could try to set up a trig equation right now, but these types of problems are so much easier when we actually have a picture. So I'd say make yourself a picture. We got some ranger on a watchtower. There he is. And he's looking down at a fire. You see some fire. So I'm going to put that line of sight, and there's some fire here. Fire. Horrible fire, but that's it. All right, so the angle of depression is 11 degrees. So again, that's the angle down from horizontal. So if that's horizontal, this is 11 degrees. I want to know how far away the fire is from the base of the watchtower. So I want to know this distance here. All right, I need to come up with a triangle. So if I go straight up and straight down like that, this is 90. There's a triangle. A couple more things I know. I know the tower is 300 feet tall, so I know that this height is 300 right there. But the 11 degrees is not inside that triangle, so I got to figure out what this angle is here in order to use trig. That shouldn't be too bad though, because those two angles together, we can hopefully see form a 90-degree angle. Those two form 90. So in a 90-degree angles, if that's a 90-degree angle and 11 of it is here, this part of it is going to be 90 minus 11. Put a little note here. 90 minus 11. 90 minus 11 is 79 degrees. So that's a 79-degree angle there. All right, now I can finally solve this. There's my angle. Across from my angle is what I'm looking for. That's X, so that'd be the opposite side. Right next to the angle here, that's my 300. So 300 would be the adjacent side. And then I got to remember my trig functions. Tangent uses opposite and adjacent. So these ones we wrote up here, they could be really useful to you. It's a good idea to have these ones written down somewhere. Tangent is opposite over adjacent, so I know I need to use tangent. In this case, tangent of my angle, 79, would equal the opposite side, X, over the adjacent side, 300. Tangent of 79, again, is just a number, so I like putting that into my calculator. I showed you the last couple of times, but this time I'm just going to type it in my calculator off to the side here. That's 5.1445. So 5.1445 equals X over 300. And then just multiply both sides by 300. My final answer is about 1,543. What are we measuring in feet? Yeah, the 300-foot watchtower. So the fire is about 1,543 feet away. Let's try one more and then we're done. All right, Jim is standing 1,000 feet from the center of the Burj Khalifa. At 2,720 feet, it's the tallest building in the world. To see the top of the building, at what angle would Jim have to tip his head? So I've got a picture of the Burj Khalifa here, but I need a picture that shows this stuff. So I got to have Jim somewhere. So let's see here. I'm going to make Jim right here. And he's standing 1,000 feet from the center of the Burj Khalifa. So that's 1,000 on the bottom. And then the Burj Khalifa goes way up there. It's huge. That's 2,720 feet tall. And then this comes back down. So if he's way down there looking up, he needs to tilt his head up. I want to find out how much he needs to tilt his head up to see the top of the tower. So I want to know what angle this is, X. All right. Once you set up the picture, rest is easy. Identify your sides. That 2720 is on the opposite side from X. So that's my opposite side. This 1,000 is right next to my angle, so that's my adjacent side. Oh, this looks like tangent again. Tangent is opposite over adjacent. So the tangent of my angle, which is X, would be the opposite side, 2,720, divided by the adjacent side. All right, well, tangent, I don't want that there. I want to get X by itself, so I need to get rid of the tangent. To get rid of the tangent, you do the tangent inverse. So if I do the tangent inverse of both sides, well, the tangent inverse of the tangent, those undo each other. We get X by itself. The tangent inverse of that, that's something you can just put in your calculator. 69.8 degrees. All right, that's the type of stuff you're going to be doing today. I'm going to ask you to do 3 problems. I'm going to ask you to do 19. I'm going to say you don't have to do 22, and then do 23 and 33. So just 3 problems, 19, 23, and 33. If you have problems with those, please stop by my office hour. I'd be more than happy to help you through with them, drawing the picture, figuring out that sine, tangent, cosine stuff, all of it. The biggest thing is just making sure you know your sine, your cosine, and your tangent ratios. So again, sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. If you know those and you can plug those angles into your calculator, it shouldn't be too bad. But I'm at my office hour if you need me.